exponentials and logarithms. And what do we have? First thing, exponentials, as you know, this is anything in power. F of x is equals to a raised to power something. Trend of this graph would be as follows. It is always positive if the coefficient, if the constant is positive. For example, y is equals to a raised to power x. If a is positive, the graph is always positive irrespective of value of x. What would happen, suppose we take an example of 3 raised to power 1, this is 3, 3 raised to power 2 is 9, 3 raised to power 3 is 27. The value keeps on increasing on right hand side, and on left hand side when it becomes negative, what would happen? 3 raised to power minus 1 is basically 1 by 3, still positive. 3 raised to power minus 2 is 1 by 9, still positive. 3 raised to power minus 3 is 1 by 27, it is still positive. So it gets closer to 0 but never touches 0. On the same axis, sketch the graph of y is equals to 3 raised to power x, 2 raised to power x and 1.5. Now if we consider the value of x as 0, anything raised to power 0 is 1, 2 raised to power 0 is 1, 1.5 raised to power 0 is 1. So all of them, they pass through 1 at y-axis, and definitely 3 raised to power 2 would be more than 2 raised to power 2. So it rises more and 1.5 rises less. So that's a general comparison between them. Now what's happening in this case? 1 raised to power x, anything 1 raised to power anything is 1. So basically there's 1 in the numerator and 2 raised to power x. When value of x is increasing, basically the denominator is increasing. Increasing the denominator reduces the overall value, so the trend shifts, but keep in mind the values are still positive. Sketch the graph of 1 by 2 x minus 3. So main thing is the y-intercept. So at x is equals to 0, when you use this value, this becomes minus 3, negative reciprocal, you take the reciprocal if the power is negative, and 2 power 3 is 8. We get the point of intersection, and later on it is just the trend. So keep changing the value of x from 2 to 3 values, you will be able to sketch the graph what the trend is. Draw an accurate graph of this. Okay, 1.7 raised to power x from minus 4 to 4. If he is expecting an accurate graph, it is on the graph paper, labeled on both axes 1, 2, 3, 4, so on. So 1.7 raised to power x, when x is 0, y is 1. So intersects at this point. When x is 1, y is 1.7. So at 1, 1.7. At 2, whatever it would be, we'll use calculator and get the exact value. The sketch stays the same. Are you getting it? If we look at this second part, use the graph to solve the equation 1.7 raised to power x equals to 4. Basically 1.7 raised to power x was y. So this means it is y is equals to 4. So you may just draw a line at y is equals to 4. Wherever it will intersect is the solution, is the value of x. This is graphical form. In later exercises, we'll be using logarithms to solve for x. Question 2 is exactly having the same nature as question 1. It says 0.6 raised to power x from minus 4 to 4. Minus 4, minus 3, minus 2, minus 1, 1, 2, 3, 4. On grid it would be easy. So 0.6 raised to power 0 is 1. 0.6 raised to power 1 is 0.6. 0.6 raised to power 2 is 0.36. So it keeps on decreasing on this side and it will increase on the other side. Then the question says in part B, 0.6 raised to power x is equals to 2. 0.6 was raised to power x was y. So y is equals to 2. So at y is equals to 2, we draw a horizontal line. We draw a horizontal line, and the point of intersection is basically the answer. Sketch the graph for y is equals to 1 raised to power x. Value of x keeps on changing, but y stays 1. So it is a horizontal line at y equals 1. Okay, exponential functions of the form a raised by x have a specific mathematical property. The graphs of their gradient functions are a similar shape to the graph of the function themselves. In the case f dash x equals k times f of x, where k is the constant, as the value of a increases, so does the value of k. Sometimes the unique value, okay, where is the question? This is 1 and 2, 3, 4, gradient function of numbered raised to power x. Differentiating the exponential general form is whatever you have, suppose e raised to power nx, dy by dx is, first you write as it is, this is e raised to power nx, then you multiply it with the differentiation of power. So differentiation of power in this case is n. This is the differentiation of exponential function. For example, y is equals to e raised to power x, so dy by dx is e raised to power x. If you have y is equals to e raised to power x square, differentiation will be first as it is, you just copy them, then multiply with the differentiation of power, which is 2x. Y is equals to 7 e raised to power 3x. So dy by dx would be first as it is 7 e raised to power 3x, then you multiply it with the differentiation of power only, so that is 3, it becomes 21 e raised to power 3x. Now these are few examples. Differentiate with respect to x. These are solved examples. E raised to power 4x first as it is, then you multiply it with the differentiation of power only, then firstly as it is, then you multiply it with the differentiation of power only. So as it is, you copy it here, then you multiply with the differentiation of power. Sketch the graph of the following equations, giving the coordinates of any points where the point crosses the x-axis, and state the equation of any asymptote. Okay, y is equals to 2 raised to power x. There is this sketch, and what the asymptote is. Basically, the line where the graph comes closer to it but never touches is the asymptote. In this case, we know that y is equals to 0 is the point where the graph is not touching but it is coming closer to it. So that is the equation of asymptote. For example, if you have this graph, any such graph which would look like this, for example, and this is getting vertical and closer to the value x is equals to 1 but never touches it. So in this case, the equation of asymptote is x is equals to 1. If you remember the graph of tan theta was like this. Remember this? This point was 90. This intersection point is 180. This line is 270. And this point is again 360. So in this graph, at theta is equals to 90 degrees, it is an asymptote. At theta is equals to 270 degrees, that is again an asymptote. The graph of tan comes closer to this vertical line but never touches it. Asymptote is that vertical or horizontal line where the graph comes closer to it but never touches it. Both. It could it could be towards any axis. For example, in this case, let me say this is y is equals to 3 raised per x. It intersects at x0, y1. Asymptote is the x-axis, which is y is equals to 0. If you continue it on the negative axis, it will come closer to the axis but never touch it. And in case of tangent, it depends what the domain is. We had 90 degrees as a line of asymptote. In this case it is vertical, and 270 again. So that depends what our domain is. So from 0 to 360 we have two asymptotes in graph of tan theta. In this graph we can clearly see what the asymptote is. The graphs are approaching the x-axis but they're not touching it. So y is equals to 0 is the asymptote. Now see this graph. Y is equal to 3 plus 4e raised to power 1 by 2x. So whatever you do with this value, we can expect this value to change by changing x, right? But this section will never change. For example, I have like I keep on increasing the value of x and I see what the variation is. Then I keep on decreasing and I see what the variation is. But this 3 actually adds up to whatever the value was there. So you see, if you decrease this value even to 0, which would not happen, but closer to 0, it is always adding up 3 to it. So the value is never decreasing from 3. The graph is coming closer to 3 but never touching it. So asymptote is y is equals to 3. Use of calculator, so that's not an issue. Just substitute x1 and get the value, x4 and get the value, x minus 10 and x 0.2 and so on. Draw an accurate graph of y is equal to e raised per x from minus 4 to 4. So plugging in all the values minus 4, minus 3, minus 2, minus 1 till 4 with the difference of 1 each, we will be able to sketch this. By drawing appropriate tangent lines, estimate the gradient at x is equal to 1 and x. This is basic geometry. For example, you have this graph of y is equals to e raised per x. So at x is equals to 1. So you just use your ruler and draw a tangent and then find the gradient. Then at x is equals to 3, you choose that point, draw a tangent and then find the gradient. Sketch the graphs of. Okay, there is a difference between accurate plotting and sketching. Sketching just includes the point of intersections with the x-axis or y-axis, and plotting would consider that you label the axis with all the values. So for example, we have y is equals to e raised to power x plus 1. Now I'm not certain because we are not memorizing it, and yes, after practice we'll be able to see how it would look like without even solving for few values. Now this is y is equal to e raised per x plus 1. So I'm thinking for some values how I should sketch it, and I see that if I use minus 2, minus 1, 0, 1 and 2 then I think when I use minus 1, I would actually get e raised to power 0, right? So when we use minus 1, this power would become 0 and anything raised by 0 is 1. So I know at x minus 1, this is 1. Secondly, when I use 0, this is e raised to power x. Now if you use your calculator, e is 2.7 something, approximately 2.7 something. So at x 0, it is, this is 1, this is 2, and this is 2.7 something. Okay, then at x1, it is e raised to power 2 and so on. So this decreases on left hand side and increases on right hand side, and this is the trend it shows. Now let me just sketch it a little neat. So it intersects at x0, y 2.7, and we can check that it becomes closer to y-axis. Whatever the value of x would be negative, it would be always positive. Why so? For example, consider it negative 99. So this will become negative 98. That is 1 over e raised to power 98. It is a very small value, but still positive. So it comes closer to that, and the asymptote will be y is equals to 0. Any confusion till now? The interesting part is actually solving algebraically using logarithms. Now this is differentiation, which is first as it is, then differentiate the power and multiply it. Let me solve some simple ones first. So 6a differentiation is firstly as it is, just copied, then multiplied with differentiation of power. So this is your answer. Look at this e part. First as it is, then you multiply it with the differentiation of power. Now yes, Mohammed. What would be the answer if I ask you to differentiate this? 6x only. 6. This is where this x is coming from. No, 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 no. The theme is y is equals to e raised to power nx. Differentiation is first you just copied. First it is copy as it is times the differentiation of power. We are actually copying it. Do not mix it with this thing. There's no exponential in this. In this we used to reduce the power. We used to do this 18x5. Okay, this is not exponential. In case of exponential, you just copy it, then differentiate the power and multiply them. So first part for this we're done. Now the second part, I'm just copying it and multiplying it with the differentiation of power. Now this is a coincidence that the differentiation is 1. So this is my final answer. F part. This is e raised to power 2x plus e raised to power x. Now I'm going to differentiate it. So when you differentiate, first copy as it is, then multiply with the differentiation of power. Second part, copy as it is, then multiply with the differentiation of power, which is 1. There's no need to write it. Look at this C part. Copy as it is, then multiply with the differentiation of power. Simplifying, this is your differentiation for this question. Now we just drew the tangents and found the gradient. Now what is the difference between that question and this question here? Question number 7. It is given y is equal to e raised to power 3x. Y is equals to e raised to power 3x. If I differentiate it, this is dy by dx first as it is multiplied with differentiation of power. So this is the differentiation. This question says find the gradient of the curve when x is 2. So I have the differentiation and this is exactly the gradient, 3e raised to power 6. This is my answer. I can use calculator to give it in decimals, but this is the exact form. One way is you sketch the graph and draw the tangent. The other way is you differentiate it and substitute the value of x. The good part is you can use any concept in any chapter during exam. We never use this because we didn't study it earlier. Now, exponential modeling, you would have heard this thing sometimes. For example, if you consider an area you prefer to live in, you might consider that the living cost in that area increases exponentially. How should I give a real life example? For example, if you consider Burj Al Khalifa, if you consider living closer to it, the more closer you get, the more exponential the prices would increase. For example, rent very far away is 1000 and you're getting closer to it, this is how the rent is going to increase. So exponential modeling, for example, if I say that this one microbe would split into two, and then these two will split into two more, then they will split into two more, and so on. So this is an exponential increase. This is not linear increase. This is exponential increase. To show you the difference, this is linear increase and this is an exponential increase. Linear, exponential. Getting the idea? Okay, let me change it. Is it more clear now? Exponential and linear increase. The density of the pesticide is given in a given section of field can be modeled by the given equation, where T is the time in days since the pesticide was first applied. So we can predict by using this mathematical expression when the value of T changes first day, second day, third day, fourth day, fifth day, and we can see what the density of pesticide is in that area. So when the value of T is increasing, the density is basically decreasing. Why so? If you can simplify this equation, because of this negative power, I can write e raised to power 0.0006 T. So increasing the value of T would decrease the overall value. Interpret the meaning of the value 160 in this model. So when T is 0 at time 0, may I say at time 0 the density of pesticide was actually 160, because at time 0 it is e raised to power 0, which makes it 1, and this would become 160 over 1. So that's 160. So interpret the meaning of 160. That means it is the maximum value of that pesticide. 160 is the maximum density of that pesticide. Or you can also say it is the initial density which then decreases up afterwards. Show that dp by dt is kp, where k is a constant. So basically it is requiring you to differentiate it. P is already there. So if I write dp by dt, what was the rule? You first copy it as it is. So this is 160 times e raised to power 160 times e raised to the power negative 0.006t. First thing. Second thing is multiplied with differentiation of power. So differentiation of power is negative 0.006. Now we can simplify it. I'm using the calculator. So 160 times 0.006 is 0.96. So 0.96 e raised to power negative 0.006 t. So if you have to guess the value of k, we can make that guess. This right here is p. P stays there, and whatever is left behind is k. So if you have to change it in that value again, we can say that this complete thing was basically p, and this is k. Negative 0.006 times 160 e raised to power negative 0.006 t. So I can write minus 0.006 into p. This is the differentiation. D part says interpret the significance of the sign of your answer to part C. So this is negative. Do you remember what this meant in our second last topic? I'm writing these two things. If dy by dx is positive, what does that mean? And dy by dx is negative, what does that mean? Anyone? Do you remember? When dy by dx is positive and when dy by dx is negative, what does that mean? Increasing function and decreasing function. This is what it means. And then double derivative would tell you that if the value point of turning point is maximum or minimum. So in this question, interpret the significance of the sign. The sign in our answer is actually negative. So what is the significance? This signifies that it is a decreasing function. So whatever the value would be at any time, when you increase the time, the value keeps on decreasing because it is a decreasing function. This is how it should look like. E part says sketch the graph of P against T. So this is it. Here comes the exercise. The value of the car is modeled by the using formula. Formula is right there, where V is the value in pounds, and T is the age in years from new. State its value when new. So when it is new, time is actually 0 minus 0 divided by 12. So without using the calculator, I can say that this part in this block is 1. So 20,000 into 1 is 20,000. So when it is new, the value is 20,000 pounds. B part says find its value. Yes. Because when it is new, it is 0 years. For example, you bought a car in 2002. Yep. That's T by 12. Can you see it now? That's T by 12. B part says find its value to the nearest pound after 4 years. So after 4 years, again using the same formula, 20,000 times e raised to power negative 4 by 12. And here comes the role of your calculator. And this is 20,000 times e raised to the power 4 by 12, negative 4 divided by 12 is 14,330.62621. So find its value to nearest pound. To nearest pound it is 14,331. Sketch the graph. We again know that it is a decreasing function. So at time 0 we already know the value is 20,000, x 0, 20, 1, 2, 3, and it keeps on decreasing, and this is the sketch. And these are similar questions which would need practice, and then our second topic would be logarithms. We'll start logarithms tomorrow, and till then we'll just practice these questions.